So we're talking about system of equations, right? And what we were looking at is different types of equations. So let me just start off by saying this. If I had to solve y equals 3x plus 2 and y equals negative 2x, 3x plus 2, and negative 2x plus 7. So let's say I had to solve that. And I think all of you realize that in order to solve this, you would simply take this and plug it in, right? That's kind of what we did on the first one. And we would get negative 2x plus 7 equals 3x plus 2. We would add 2x. 7 is equal to 5x plus 2. Subtract 2. 5 equals 5x. And x is equal to 1 if you divide both sides by 5. Once you get x equals 1, you plug it in. 3 times 1 plus 2 is 5. So the answer here is 1, 5. Does that make sense? Now, what I want you to see is this, that if I were to take this and I would take these two equations and I would graph them. If I graph 3x plus 2, what does that graph look like? If I graph 3x plus 2, 3x plus 2 starts here at 2, right? That's my you are here point. Then we're going up 3 over 1, yes? And so what I have is kind of this straight line. That was just terrible. Watch this, though. So I had that straight line, right? Now, if I graph the other one, negative 2x plus 7, negative 2x plus 7, so we're here, right? And then I go, this is 7. I go down 2 over 1. I'm here, yeah? Does everybody understand that? Does everybody see that? And so, what does the point 1, 5 that we got here? Notice the answer we got was 1, 5. What does that point have to do with this picture? It's where they intersect, right? And so the answer is where the graph intersects when you draw it, right? And then what happened on the first one is the problem was y equals 4x minus 7 and 8x minus 2y equals 12, right? And when we solve that, we plug this into y. We got 8x minus 2 times 4x minus 7 equals 12. 8x minus 8x plus 14 is equal to 12. And then those canceled, right? And it was at that moment that we went, oh, crap. That's not supposed to happen, right? And then we said, okay, well, 14 equals 12 is no solution. But let's look at if we were to graph this. If we were to graph that, what does it look like? So here's what we're going to do. We're going to go Tools, Insert, Picture, Graph. Oh, shit. We're going to undo. Don't play with me. What the hell are you doing? We're going to do 4x minus 7, yes? So what does 4x minus 7 look like? Here's 7. 4x would go up 4 over 1, right? So we're going to go up 4 to the right 1. Well, we ain't going up 4 right 1 because we're already off the dang on graph. So what are we going to do? Go down 4, left 1. 1, 2, 3, 4, left 1. So we're here. Does that make sense? Now, we're going to do this, and we're going to draw this line. Does that make sense? Now, let's look at the other one. What's the other one? 8x minus 2y equals 12. Do we agree? So now what's going to happen? We're going to negative 2y equals negative 8x plus 12. Do we agree? We're going to divide by negative 2. We're going to divide by negative 2. We're going to divide by negative 2. We're going to get y equals 4x minus 6. Does that make sense? So now let's graph y equals 4x minus 6. 4x minus 6 is you're down at negative 6. You're going to go up 4, 1, 2, 3, 4 over 1. And you're going to graph that line. Now, where do they intersect at? They don't. So graphically speaking, what you see here by no solution is simply the fact that these two lines don't cross ever. Does that make sense? That graphically, that's what it means when I get to a point where I say the answer is no solution. Now, where this runs into issues is this. And what you see here where we got 0 equals 0, just to show it, what you have is 12x minus 18y equals 24, and 4x minus 6y equals 8. When if you did 6 and 18 and made this one negative, that would work. By the way, just multiplying the bottom equation by negative 3 would also get the job done. Just so you know. All right, some people go like this, oh, you tricky. Yeah, I mean, negative 3 would got the job done too, but it doesn't matter. Ultimately, you get to 0 equals 0. But what does that look like? What does that look like? Here, let's just quickly find the x and y intercepts. Let's quickly find the x and y intercepts. So, for this, do we agree the x-intercept is 2? Plug in y is 0. Solve for x, you get 2. Plug in x is 0. You get 24 over negative 18. That's the y value. Does that make sense? We can reduce that and make that negative 4/3. Do we agree? Let's do the same thing for this. Plugging in y is 0. Plugging in y is 0. I get x is 2. X is 2. Do we agree? And then plugging in x is 0, you get negative 4/3. 8 over negative 6. Does that make sense? So notice what we have. For the first equation, the x-intercept is 2, 0. The y-intercept is negative 4/3. The graph looks like this. Right? The next equation, the x-intercept is 2, 0. The y-intercept is 0, negative 4/3. And that graph looks like this. Where do they intersect? Where do they intersect? Some people go like this. Well, they intersect there and they intersect there. Shit, they intersect here too. They're the same exact line, right? So where do they intersect? And a lot of people go like this. Well, then hell everywhere. No, it ain't everywhere because guess what? They damn sure ain't intersecting over there. Does that make sense? Like, you can't say all real numbers like, oh, it just intersects everywhere. It's just like God. It's just everywhere. No. It intersects everywhere on this line. Does that make sense? It intersects everywhere on that line. Now, here's the hard part. How do you write that? Now, I really feel terribly bad for you, right? Because remember what you've already seen as it relates to domain, right? You've already seen this. And you know the first time you thought, you went to yourself, what the heck is he doing? Because nobody that's not been in the class before ever thinks that is even a legitimate answer. Right? But you do it and I go like this, good job. And then you're like, okay, well, that's just like, that reinforces the behavior. Oh, Dreyer says, good job, but I do that. I'll do it again. Okay? The way you write this answer, you don't say all real numbers. This is no good. Here's what you can say. Here's what you can say. Identity. That's an acceptable answer. I'll give you credit. And that's the one you probably like, actually. Because the other one, not so much. It looks like this. All ordered pair XY such that 12x minus 18y is equal to 24. This is the way the book does it. All ordered pair XY such that 12x minus 18y equals 24. This is the way the book will do it. Okay. Students will go, is there a different answer? Sure. All ordered pair XY such that 4x minus 6y is equal to 8. That ain't a whole lot better. Okay. Most students in intermediate algebra choose this as their way of writing it. Okay. And if you wrote all real numbers, I would probably just take off a point because you've demonstrated you understand what's happening. You just haven't quite gotten terminology correct yet. Okay. So anyway, that's graphing, and that's understanding system of equations and solutions of the three types you can have. Okay. Type 1, they meet and hit at a single point. And when that does, that's a final answer, and you just put whatever that point is. All right. Number 2, they don't meet at all. The lines are parallel, and we say that's no solution. And then option 3 is the two lines are actually the exact same line, and then they meet all over the dang on place. Okay? Any questions on that?